Just a second here. We have done ammonia, water,
Yes.
right? Now today I'll be discussing about how to decide shape of molecule. I mean three-dimensional shape of molecules.
Yes, sir.
When I talk about three-dimensional shape of molecules, we have a theory VSEPR theory.
Okay.
It is a valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. According to this theory, a molecule has some lone pair of electrons and some bond pair of electrons. Some lone pair and some bond pair
One.
of electrons are there. You know what? What are the lone pairs?
Yes, so the electrons in the outermost shell that do not take place in the sharing or
Yes,
gain or loss.
they are present in the outermost shell, but they do not take part in bonding. That is called as a
Bonding.
lone
Lone.
pair of electrons. Between these lone pairs and bond pair of electrons, there is a repulsion. So the bonds are aligned at a particular angle where they get minimum repulsion. Bonds are aligned in space where they get minimum repulsion and maximum stability. Minimum repulsion and maximum stability. Right?
Yes, sir.
Maximum stability. The magnitude of repulsion is maximum between two lone pairs, less in case of the lone pair and a bond pair, and least between two bond pairs. Right?
Yes, sir.
This is about the repulsion. Repulsion is maximum between two lone pairs. Less in case of lone pair and a bond pair, minimum between bond pair and a bond pair. The repulsion will be maximum when the two bond pairs are 90 degrees to each other. As the bond angle increases, when they're pushing apart, pushing each other, the repulsion goes on decreasing.
Mm. Mm.
Right? And
Yes, sir.
these two factors will decide the shape of the molecules. So I'll be considering or I'll be taking different examples of different types, different number of bond pairs, lone pairs, and we decide the shape of the molecule.
Yes,
First
sir.
category, I am considering AB2 type of molecule, where we have a two bond pairs and zero lone pairs. For example, I have BeCl2.
Mm.
In this molecule, I don't have any lone pair on chlorine, on beryllium. How do I know that it does not have any lone pair? From its electronic configuration.
Yeah.
Beryllium atomic number 4, right?
Yes, sir.
So
And S
electronic
two, S two.
configuration 1s2, 2s2. These two electrons will take part in bonding, and I don't have now any more pair of electrons in the outermost shell which is not taking part in bonding. It means now I have a two bond pairs. These two bond pairs are repelling each other, and due to this repulsion, here bond angle is 90 degree and here bond angle is 120 degrees. Still it can repel more, and the final structure where the repulsion becomes minimum and stability maximum is at 180 degrees Celsius. 180 degrees. So the shape of
Mm.
the molecule is
Mhm.
linear.
Yes, sir.
Am I clear?
Yes, sir.
Shape of molecule is linear. Till now, any doubt?
No, sir.
Okay. Now I'm considering next case now. Again, I have an AB2 type of molecule where we have a two bond pairs and one lone pair. For example, I have a tin chloride, SnCl2. Two bond pairs and one lone pair. Lone pair, we show it like this, right?
Okay, sir.
This lone
Yes, sir.
pair will repel the bond pair.
Yes, sir.
Due to this repulsion, these bonds will come closer like this.
Yes, sir.
But now when they come more close, there is also bond pair repulsion also.
Mm.
And here we have a
Yes, sir.
lone pair and a bond pair repulsion.
Mm.
So there is some net angle at which these two bonds pair will be aligned. So this shape is V shape or bent shape. I hope it's very clear.
Yes, sir.
Should I go ahead?
Yes, sir.
Okay. Now again I am considering AB2, where again I have a two bond pairs, but this time I have a two lone pairs.
Mm.
For example, we have water. Two bond pairs are there and two lone pairs are there.
Yes.
These lone pairs will repel each other,
Yes, sir.
and the lone pair will repel the bond pair also.
Yes, sir.
As a result, the bonds will come closer and repel, lone pair also repel each other. Right? Again,
Yes.
shape is again V shape or bent shape.
Yes.
Can you tell me out of the SnCl2 and water,
Mm.
which will have a smaller bond angle?
The H2O, because there's more repulsion between lone pair, lone pair.
There are two lone pairs are there,
Yes, sir.
which are repelling the bond pair. But in case of SnCl2, I have only one pair, one lone pair that is repelling here. Right?
Mm.
We can compare the bond angle, right? I'm not telling you the exact bond angle, what it is. We don't need to remember it even, right? But we should be able to compare which is bigger bond angle or smaller bond angle on the basis of this VSCPR theory,
Yes,
right?
the
But
more the lone pairs, the smaller the angle.
yes, so I can, and now I'm giving a very popular angle for the water, you should know, 104.5 degrees.
Okay, sir.
For water, you can keep in mind, right? Because very
Yes,
common
yes.
molecule. So okay,
Yes, sir.
again you come to the next one, that is a AB2, again AB2, but this
Yes.
time I have two bond pairs and four lone pairs. It means total pair of electrons around the central element are 6,
Hmm.
right? For example, I have an XEF2, xenon difluoride. You know, xenon is a noble gas.
Yes, 8 valence electrons.
8 valence electrons are there. Out of the 8, 2 are involved in bonding with the fluorine.
Hmm.
And 6 electrons means I can say 3 pair of electrons.
Yes, sir.
We can 3 lone pair of electrons.
Yes, sir.
Total pair are 6. Total pair of electrons are 6. What is this? No, 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 no.
Total. Hmm.
No, 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 no. XEF2. Yeah, okay, okay. Their total pair are 5. 5 pair of electrons are there. 5 pair. Yeah. And these 5 pair of electrons align in 3-dimensional space in this way. In one plane, this is above the plane and below the plane. And the
Yes, sir.
lone pairs are aligned on the trigonal planar geometry. Trigonal
Yes.
planar geometry. Got it now?
Yes, sir.
Right. This angle is 120 degrees and this
Hmm.
angle is 90 degrees. And shape is again linear because the molecule atoms are aligned in,
180
yeah,
degree.
this shape is called as a linear shape, but the geometry is called trigonal bipyramidal. Trigonal bipyramidal. Got it now?
Yes, sir.
Because in trigonal plane you can see one pyramid above and one pyramid down. Can you see like that? If I connect
Yes, sir.
this like this, right? One pyramid above and one pyramid down, so we call it a trigonal bipyramidal.
Only taking the bonded electrons, and when we're talking about the geometry, we
Yeah,
also include the lone.
yeah. So I have discussed all the cases of the AB2 type of molecule. When I A and B2. Now I'm considering A, B, 3 type of molecules. AB3. First case I'm considering here is there are 3 bond pair of electrons and 0 lone pair of electrons.
Hmm.
3 bond pair and 0 lone pair. Okay,
Yes, sir.
3 bond pair and 0 lone pair. For
Yes, yes, sir.
example, I am considering example of a boron trichloride. So this boron and 3 chlorine may be aligned like this, but at this angle, 90-degree angle is highly repulsion. So they will
Hmm.
repel to the maximum, and in one plane they can be aligned at 120 degrees.
Hmm.
right? Because total angle is 360 divided by 3,
Yes, sir.
right? So it is a 120 degrees, where they will get minimum repulsion, maximum stability. This is trigonal planar geometry,
Yes, sir.
trigonal planar shape or trigonal planar geometry. AB3 type of molecule where we have 3 bond pairs and 0 lone pair.
Yes, sir.
Now next one is again AB3 type of molecule where we have 3 bond pairs and 1 lone pair. For example, we have a molecule of ammonia, NH3. Here I have a lone pair of electrons and here I have a 3 bond pair of electrons. This lone pair repel the bond pair.
Hmm.
Now this bond angle, the third bond, see the third bond. If I make it like this, the bond angle will be even less than that of the 90 degree,
Yes, sir.
and that makes it highly unstable.
Hmm.
So what will happen with the third bond, that it will go out of the plane, it will go either towards the observer or away from the observer. It becomes three dimensional.
Yes, sir. Oh,
Consider like towards you or away from the screen,
yes, sir. Okay,
towards the
got it.
observer or above, right? So when you're showing like this dotted line, wedge dashed like, it means it is away from the observer, or you can show towards the observer by this wedge formula,
Okay, sir.
right?
Yes, sir.
This is, if you join all these points here, this is pyramidal.
Yes. Yes, sir.
In case of the ammonia, the remember bond angle 107 degrees,
Yes, sir.
right? Understood?
Yes, sir.
Now again, I'm saying AB3 type of molecule where we have 3 bond pairs and 2 lone pairs. Example ClF3. Whenever we have 5 pair of electrons, it acquires trigonal bipyramidal geometry.
Yes, sir.
So the 3 fluorines are like this and 2 lone pairs at this angle.
Hmm.
The shape is T shape. You know, T is bent, tilted on one side,
Yes, sir.
right?
Yes, yes.
T shape.
Hmm.
Did you go ahead?
Yes, the shape is T shape, but geometry is trigonal bipolar.
Yes.
Yes, sir.
Now, next case I'm considering here is the AB4 type of molecule where we have a 4 bond pairs and 0 lone pairs.
Hmm. Carbon tetrachloride.
Right. For example, we have methane. Simplest example I can consider here.
Yes.
I can draw the structure of methane like this. when they all are at 90 degrees. But this is highly
Yes,
unstable, highly unstable. At 90 degree, the bond is highly unstable. These bond
yes,
pairs will now repel, and now the fourth angle will be either towards the observer or away from the observer. The angle becomes 109 degrees and 28 minutes, and this geometry is called tetrahedral.
okay.
Tetra means four and hedral means face. It is a four-phase
Yes,
geometry. Right? If you connect all this point here, you can see the four faces are there.
yes.
There's a four-phase geometry, tetrahedral AB4.
Hmm.
Understood?
Yes,
Now, next. Again, AB4. Where we have four bond pairs and two lone pairs. For example, I have XEF4. Xenon has 8 electrons, out of which 4 are
yes,
involved in bonding.
yes, sir.
Other 4 will be making 2 lone pairs,
Yes, sir.
right? 4 bond pairs and 2 lone pairs. So total are 6 pair of electrons
Yes, sir.
that will align in the octahedral geometry. In one plane, I have 4 bonds of the fluorine,
Hmm.
and the lone pair are above and below the plane. So I can say 4 bond pairs and 2 lone pairs are there,
Yes, sir.
right? 4 bond pairs and
Yes,
2 lone pairs are there. So the bonds are aligned in one square plane. So the shape is square planar. Geometry is octahedral. Geometry is
yes,
octahedral. Geometry is octahedral. Am I clear?
yes, sir. So, what would be the angle between the fluorines?
Pardon?
What would be the angle between all the
Yeah,
fluorines?
all these are angles are 90 degrees.
Then wouldn't the repulsion be very
There,
high?
there is no other option now.
Acha, हाँ.
In this case, there is no other option to go away or
Yes,
to
sir.
more go away, right? They will come closer even if they try to push apart each
Yes,
other.
yes, sir. Yes, yes, sir.
Now I'm considering now A, B, 5 type of molecule. When I talk about the AB5, I have 5 bond pairs and 0 lone pairs, right? Example is now PCl5, phosphorus
Hmm.
pentachloride.
Yes, sir.
Whenever we have 5 bond pairs, 5 pair electrons, it will acquire trigonal bipyramidal geometry,
Yes, sir.
right?
Yes, sir.
This angle is 120 and this
100.
angle is 90 degrees.
Yes, sir.
The one that I'm shading with the green up and below, these
Hmm.
bonds are called axial bond, and this is called as a equatorial bond. axial bond and equatorial bond.
Yes, sir.
This axial bond has been found to be longer than equatorial bond. Question arises here, why? Question arises here, why?
Mm.
The reason behind this is, if you talk about the AB means axial bond, that is perpendicular to the three equatorial bond. Is that right?
Yes, sir.
Okay. It means I can say the axial bond is repelled by three equatorial bonds,
Yes, sir.
right? And if you talk about the equatorial bond, that is perpendicular to the two axial bonds,
Yes, sir.
right? It means it means equatorial bond is repelled by the two bond pair of electrons, two axial bonds.
Um,
So
Yes,
which is
sir.
experiencing more repulsion?
AB.
AB. Since it is experiencing more repulsion, and that is why axial bond is longer than equatorial bonds.
Okay, sir. Yes, sir.
Understood?
Yes, sir.
Now, in case of SF6, it's a AB6 type of molecule. SF6 or AB6 type of molecule, where we have a 6 bond pair of electrons
Mm.
and 0 lone pair of electrons. 0 lone pair of electrons, right?
Yes, sir.
The shape will be octahedral, where whenever we have 6 pair electrons, sulfur 1, 2, 3, 4, 5, and 6.
Yes, sir.
This is octahedral shape.
Yes.
Note it down.
Yes, sir. So octahedral can also be called square bipyramidal, like we said in the trigonal
We
bipyramid.
can say. But normally we say octahedral because of the 8 phase structure. 4 phase above, 4
Yes.
phase below, right? Now, next is now AB7 type of molecule. Like we an IF7, iodine heptafluoride.
Mm.
Make a pentagon in one plane.
Mm.
Iodine in the center. One fluorine up and one fluorine down.
Mm.
Rest in the plane. This will be called the pentagonal bipyramidal.
Yes.
It is pentagonal bipyramidal. Am I clear?
Yes.
So these are the different shapes which are possible, right? Compound to compound, it will vary. We'll be discussing different cases, but basic structure will remain same,
Yes, sir.
right? Any doubt till now?
No, sir.
No doubt. Wait a minute. These postulate angles all we have done, right?
Yes.
Different possibilities we have done, but now right now we are discussing about this question based upon this whatever we have done right now.
0, 1, 2, second option.
0 1 2, good.
First option.
Yeah, okay. Now these are the different cases that we have already done,
Hmm.
right?
Yes,
In the
sir.
AB type the bond angle is linear, I had discussed.
Mhm.
I
Yes, sir.
discussed only one example, BeCl2. You can add more,
Yes, sir.
you can add here more examples in that AB2. You can add more example, HgCl2, BeF2, MgF2, H, all this you can write down
Yes.
these more examples.
Yes, sir.
AB3 trigonal planar, right?
Yeah.
I discussed only with BCl3. You can add more. Boron trifluoride, aluminum trichloride, aluminum trifluoride.
Yes, sir.
AB4 tetrahedral.
Hmm.
Methane we have discussed. You can add here
Yes,
carbon
sir.
tetrachloride.
Hmm.
These are the molecules where we are not considering any lone pair, right?
Hmm.
All are bond pairs. AB5 trigonal bipyramidal. We had discussed a PCl5.
Yes, sir.
Okay.
Hmm.
Now, AB6 octahedral. All angles are.
Yes.
Now, if we have AB2L, L means one lone pair,
Very well.
two bond pair and one lone pair, two bond pair and one lone pair, like this. It will become a shape trigonal planar bent structure. SnCl2 example I had discussed here. PbCl2 we can discuss here, right? That we have already done, but only in the I discussed AB2 with a two bond pair and one lone pair.
Yes, sir.
Same thing I am representing here. AB2L means two bonds and one lone pair.
Yes, sir.
Rupashi, are you getting this?
Yes, sir.
You're not getting confused, I hope. Okay, leave all these
No.
things that we have already done. Come to the questions basically. I'm working upon the questions now. Okay, now work upon this question now.
SF6.
Yes.
4 bond pairs and 2 and 4.
Hmm. Okay. Okay. Leave these things now. Can you answer this question?
Yes, sir, because the angle is more in the equation. That's 120 degree. There's 90 degrees. The repulsion will be less when the angle is more.
SF4, SF4.
Yes, sir, that will be trigonal planar. So
No, no,
when we
no, no, no,
arrange,
no, no. Trigonal planar नहीं है. It has
sorry, trigonal bipyramidal.
bipyramidal. The lone pairs are
Yes,
here, right? We're putting
yes.
the
So the
video
angle will be,
between this the one lone pair. Okay. Now we are not putting it on the axial position, right?
hmm.
If I put it on the axial position, then why we are not putting it here? Why this is unstable, or why the first one is more stable?
Hmm.
I can put anywhere, right?
Yes, sir. So because there it is perpendicular to two fluorines, whereas here it's perpendicular to the three fluorines.
Absolutely correct. Here it is repulsion to the 2 fluorine and here repulsion to the 3 fluorine, right?
That will
That
yes,
will
sir.
be make it unstable, right?
Yes,
Okay, okay, good. Shape of the molecules.
octahedral for the first one.
No, 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 no.
Nee, tetrahedral.
Tetrahedral. The first one is
Yeah.
tetrahedral.
Yes. I got it.
Si,
Yeah.
yeah, SiF4. So all these angles are 109 degrees, 28 minutes, right, Rupashi?
Yes, sir.
Okay, now come to the next part now.
Yes, sir. Bent,
Bent. How many lone pairs?
two lone pairs
And
and
how
two
many
bond
bond
pairs.
pairs? Two bond pairs.
Two.
And it is negatively charged, right? You can
Yes,
you
sir.
can get it from the ammonia. Remove one H positive,
Hmm.
right? Okay, come to the next one. NH4 positive.
Yes. Tetrahedral.
Yes, tetrahedral. But there is a positive charge on the central atom.
Yes, sir.
Can you tell me why?
So because nitrogen can only form three bonds and it's H4, so it needs an extra pair for the
So lone
air.
pair, actually lone pair on the nitrogen is donated to the one of the hydrogen.
Yes, sir.
In case of ammonia, if it is ammonia, one lone pair is given to the H positive. Okay, next
Yes.
one. This you have done in the 10th class, right?
Yes, sir.
Linear molecule.
Linear, yeah.
Note it down.
Yes, sir.
Okay, come to the question.
Trigonal bipair. No, एक second. No, 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 no. 1 second. Bent, T shape.
T shape, yeah. Right now we have done.
Yes, sir.
Okay.
Lone pair, lone pair. Pentagonal bipyramidal. First option.
Hmm.
One lone pair in the equatorial position.
Equatorial position. Good. Leave this. VBT we have done, right?
Yes, sir.
Okay. Valence bond theory we have done. Based upon this, let us do these questions now.
No, we have not done this.
We are not done? No.
No, sir.
Okay, leave it. I'll come to the theory now. Just a second. Now, we have done the Lewis theory, octet theory, and we have also discussed its limitations also, right? And
Yes,
now
sir.
we talk about valence bond theory of bonding. Rupashi, how did you came to know about me at of online classes?
Sir, I'm not very sure. My mom found you
Uh,
somehow.
okay, okay. Because I have been advertising on the online also, and also
Yes,
through
sir, through some online people.
okay, and also through there's some teachers in Chandigarh who are my good friends. They are also maybe they may might have.
Maybe. I'm not sure.
Okay, okay. Just I
Yeah.
wanted to know that by which source you came in my contact. Anyways, some lucky people come in my contact.
Yes.
Don't you feel? Isn't it that you are now
Yes, sir. Yes.
you feel more comfortable with the subject now? Right.
Yes, sir, for sure.
Okay. I'm not boasting about myself, but this is. But what my student tell me about sometimes that sometimes subject is taught in such a bad way, it becomes like we have to remember it, we have to memorize the subject, right? But with me, it is not.
Yes.
It is not so, right? You're understanding step by
Yes.
step, right?
Yes, sir.
Of course, in chemistry, we have 30% learning. You have to remember tetrahedral means 109 degree that you have to remember, right?
Yeah.
But how it is tetrahedral that I have taught you.
Yes, sir.
So you need learning with understanding.
Yes.
That is more important. Of course, if I had remember your name, Rupashi, right?
Yes, sir.
Then it's not just remembering your name. I learned your name by some logic.
Really.
Really. I always make some logic. I always make some explanation about it. Why your name is Rupashi. Or there may be some trick that I have remembered it. Right?
So how?
How? Okay. Do you know Hindi?
Yes, yes, sir.
Okay. So संधि विच्छेद कर दो इसका रुपाशी का.
Yes.
What is that संधि विच्छेद?
Roop plus Ashi.
Yeah, basically Roop means beauty, right?
Yes.
And Ashi basically is ईश्वर, right? तो आप
Yes.
रूप के ईश्वर हैं. मैं to
Oh.
beauty god, god of beauty. Right. So that's how I try to remember certain names. Right. Okay.
Yes.
Okay. This is logic. I don't cram the
Yes, sir.
subject. I don't cram the subject. Your mummy's name is Anamika, right?
Yes, sir.
Okay. So no name. Anamika means
Hmm.
no name.
Yes, sir.
Or the person who cannot be named.
Yes.
Right? If you name it, that you're putting in some boundaries. It means beyond boundaries. When someone works beyond all boundaries, that is Anamika.
Oh.
Right? So when I talked with her, she the way she talked me, she was without boundaries. Okay, anyways, you know better. You know better.
Yes, sir.
Okay. Sometimes we are according to our name, sometimes we are not according to our name. Right? Okay, now come to Valence bond theory. That was just a
Yes.
2 minute break of the class out of the chemistry. Okay. Valence bond theory.
Hmm.
According to this theory, the unpaired electrons which are present in the outermost shell,
Hmm.
unpaired electrons in the outermost shell, their orbital overlapping takes place. Orbital overlapping takes place, and that overlapping make a bond.
Hmm.
That makes a covalent bond. Basic theory is this.
Yes, sir.
Now we come to the molecule. Apply this to certain molecules.
Yes, sir.
H2 molecule. I have here two hydrogen atoms. Two hydrogen atoms. They have this electronic configuration. But now one with a positive spin, other with a negative spin.
Hmm.
Their orbital overlapping. This is the outermost shell, and their orbital overlapping takes place here.
Yes, sir.
The bond is formed between these two hydrogen atoms. Single covalent bond is formed.
Yes, sir.
What is the shape of the s orbital?
Spherical shape.
Okay, so one s orbital of the first hydrogen, second hydrogen atom. Now they are overlapping head to head,
Hmm.
and the electrons remain in the overlapping region. This forms sigma bond.
Yes, sir.
This forms sigma bond. Okay, now sigma bond. Whenever there is a head to head overlapping, they form sigma bond. Now let us make F2 molecule. F2. One fluorine atom, atomic number 9.
Hmm.
One S2, two S2, and 2p5. Second fluorine, atomic number 9. One S2, two S2, and 2p5. The unpaired electron orbital overlapping will take place. Can I see that?
Yes, sir.
Just a second, please. Yes, hello.
Yes, sir.
Is that clear?
Yes, sir.
So the p orbital is overlapping here,
Yes, sir.
right? What's the shape of the p?
The dumbbell shape.
Dumbbell shape. So 2p orbital of the one fluorine overlapping with the 2p orbital of the second fluorine.
Mm.
They undergo head-to-head overlapping
Mm.
and form a sigma bond, right? Sigma bond.
Yes.
Got it now? Sigma and pi bond. Sigma bond between 2p and 2p.
Yes, sir.
Yeah. Pi bond I have not taught yet. Any doubt?
No, sir.
So Rupashi will now continue next time. Next class
Yes, sir.
on Tuesday morning for 8 o'clock.
Yes.
The timetable that we have made, right? Okay then. I'm ending session now. See you on Tuesday morning,
Yes, sir.
8 o'clock. Okay, goodbye.
Thank you, sir.